Hi, my name is Samir Desai, and in this video, I'm going to teach you how to rank a molecule's reactivity based on its conjugate Ka or Kb.
As we learned in the previous video, the relationship between the acid dissociation constant, Ka, and the base dissociation constant, Kb, is best represented through the autoionization of water. In the autoionization of water, two equivalents of water react to form a hydroxide ion and a hydronium ion. Water is an amphoteric species, meaning it can act as an acid or a base. Notice that one water was deprotonated to form hydroxide, or this acid was deprotonated to form a conjugate base. While one water acted as an acid, the other water acted as a base, and when protonated formed a hydronium ion, or a conjugate acid. Now, if we multiplied the Ka and the Kb of the conjugate acid-base pairs, we'd get Kw, the autoionization constant of water, which at 25 degrees Celsius is equal to 1 times 10 to the negative 14th. Since Kw is a constant, it creates a straightforward relationship between Ka and Kb. If we manipulate the equation and divide both sides by Kb, we get a Ka that equals Kw over Kb. This makes the relationship a little bit easier to see. As the Ka of an acid increases, then the value of Kb on the conjugate base must decrease proportionally to maintain the ratio. And just like we can isolate Ka in the expression, we can also divide both sides by Ka to isolate Kb. What we get is Kb equals Kw over Ka. As the Kb of a base increases, then the value of Ka on the conjugate acid must decrease proportionally to maintain the ratio. Let's apply our knowledge of the relationship between Ka and Kb to a question. We're asked to rank the reactivity of the acids from least reactive to the most reactive, and are given Kb. What information will be helpful in answering this question? In an earlier video, we reviewed trends related to Ka. The most reactive acid will also dissociate in solution the most, and Ka is a value which measures the dissociation constant. Therefore, the most reactive acid will have the largest Ka. This means the least reactive acid, the one least likely to dissociate, will have the smallest Ka. So if we rank these acids in order of increasing Ka, we'll also be ranking them in terms of increasing reactivity. It seems like there's a problem though. Ka isn't a value that was given to us, so is there another way to rank these without the acid dissociation constant? Of course there is. Recall the relationship between Ka and Kb. Ka times Kb equals Kw, and we can isolate Ka so the equation looks like Ka equals Kw over Kb. Since we know the value of Kw as 1 times 10 to the negative 14th, and we know the value of Kb, we can individually solve for the Ka for each acid. This would be a rather time-consuming process though. Rather, let's look at trends. What did we say would happen if we increase Kb? Ka and Kb are inversely proportional, so an increase in Kb would result in a decrease in Ka. Alternatively, a decrease in Kb would result in an increase in Ka. Combining all of these components tells us that the least reactive acid will be the one with the smallest Ka, which means the conjugate base will have the largest Kb. Therefore, hypochlorite, the one with the largest base dissociation constant, meaning it's the most reactive base, will have a conjugate acid, hypochlorous acid with one extra proton, that is the least reactive acid. And the most reactive acid will be the one with the largest Ka, which means the conjugate base with the smallest Kb. So the chloride ion will be the least reactive base, meaning the associated acid, hydrochloric acid, will be the strongest, most reactive acid. Now that we know the most and least reactive bases, the remaining two, fluoride and acetate, must be in the middle. The more reactive conjugate acid can be determined by identifying the less reactive base, or the one with the smaller Kb. Since fluoride has a smaller Kb, then its conjugate, hydrofluoric acid, is the second most reactive. That leaves the conjugate of acetate, acetic acid, as the second least reactive. In this lesson, we have to combine our knowledge of dissociation constant trends, like reactivity and strength, with the relationship between Ka and Kb. You should now feel comfortable with the relationship between Ka or Kb and its conjugate. Make sure to follow up with practice questions to solidify this concept.